In the following lecture, we're going to predict the redox reaction that's going to take place between chromium 2 plus ions and Cr2O7 2 minus ion. And it's an acidified solution, which means that there would be H plus 1 ions present in the solution as well. So you have 3 species that are present, and we are going to now use the data booklet to containing the electrode potential tables to figure out what the reaction is going to be, what the redox reaction is going to be. So step 1 is that we need to write all standard electrode reactions. We're going to look all these reactions up in the data booklet for the above reactants. So these are my reactants, and I'm going to now open the data booklet. So here I have opened the data booklet, and the first thing is I'm going to search for Cr2 plus. As you can see that there are 2 electrode reactions that have Cr2 plus. I'm going to mark them. There is Cr2 plus ion involved with this, where it's gaining electrons to form chromium. So it's in equilibrium with chromium, and chromium 2 plus, they are in equilibrium, and the electrode potential is given as minus 0.91 volts. The other one is over here. There's another electrode containing Cr2 plus, but this time it's getting oxidized, losing electrons to form Cr3 plus and vice versa. So there's an equilibrium established between Cr3 plus and Cr2 plus ions, and the potential given is minus 0.41 volts. So I'm going to mark that one as well. Then we also had the dichromate 6 ion, which is Cr2O7 2 minus. So it's given over here. There's an electrode, and it was acidified. So there's H plus 1 ions present as well. So we can use this electrode as reaction, where dichromate 6 is in equilibrium with chromium 3 plus. So let me use this particular electrode and mark that. I've marked this electrode over here. The electrode potential for this is given as 1.33 volts. So I have marked all the electrode reactions that involved Cr2 plus ions or Cr2O7 2 minus ions or H plus 1 ions. Now I'm going to copy these electrode reactions. So I've copied the 3 electrode reactions that involved Cr2 plus ions, dichromate 6 ions, H plus 1 acidified ions. So I've copied these 3 electrodes. Now I'll move to the next step, which is that the higher potential would have a tendency to gain electrons or get reduced, and lower potentials, electrode potentials, are the ones that are going to lose electrons and are going to get oxidized. We also need to keep this in mind, that the oxidized and reduced species, whichever substance we are getting is going to get oxidized or reduced, should be part of our reactants. Remember, we just had 2 reactants, Cr2 plus and Cr2O7 2 minus acidified ions. So whichever substance is getting oxidized or reduced, it must be either of these 2. So these are your reactants. So I'm going to look at the 3 reactions, and I'm going to try and figure out which one has the highest potential. If you look at the third reaction has an E naught of 1.33 volts, which is greater than the other 2 compared. If you compare it with the other 2 electrode potentials, it's 1.33 volts. So which means that the higher potential is going to gain electron, it's going to get reduced. So between these 3, this reaction would go in the forward direction, because in the forward direction electrons are being gained, because this had the highest potential, which is why this substance would be reduced, would have the highest tendency to get reduced. And if you look at the reactants are Cr2O7 2 minus ions plus the H plus 1 ions, and we have this reactant over here, Cr2O7 2 minus 1 2 minus ions acidified. So this is the species that is getting reduced, it's gaining electrons. Let's now try and find the substance that is getting oxidized. So lower potential is the one that's going to lose electron or get oxidized. So if you look at the 3 equations, lowest potential is the first one. It has the lowest potential, so it's going to get oxidized, which means that it's going to lose electrons, and the only way it can lose electron if it goes in the backward direction. So the highest tendency for the substance to lose electron is this first one. But we have a problem now. If we select this first equation, then it's going to be chromium that would be losing electrons to form chromium 2 plus. So chromium would be our reactant, but the problem is that if you look at our reactants, there is no chromium. There is Cr2 plus ions, but no chromium. So I would not be able to use this reaction, because chromium is not present in our reactant. So I'm going to remove this equation because this equation does not fit with my reactants. Now after removing this that equation, I'm going to repeat the whole process again. Look at the lowest, the lower potential is the one that's going to lose electrons. So you just have 2 equations now. This is your lowest potential now. which means that this electrode is the one that's going to lose electrons. So for it to lose electrons, this reaction must go in the backward direction and produce electrons. So chromium 2 plus is the one that's going to lose electrons to form chromium 3 plus. And if you look carefully, the reactant is chromium 2 plus, which if we look at our reactants that were given initially, we do have chromium 2 plus, which means that this reaction fits perfectly with the reactants given to us. So finally, if, the summary is that Cr2O7 2 minus 1 ion, because it had the higher potential, is the one that's gaining electrons to form Cr3 plus. So this is the one that's getting reduced. It is gaining electrons, and the other substance Cr2 plus is the one that's losing electrons because it has a lower potential, is the one that's losing electrons to form Cr3 plus. So Cr2 plus is the one that's getting oxidized. Step 3 now is that you need to balance the number of electrons gained and lost, and you have to write an overall reaction now. So I would first need to rewrite these equations. So if you look at the first equation, remember the first reaction is going in the backward direction. So I need to write this reaction in the backward direction, where Cr2 plus is the one that's losing electrons to form Cr3 plus. So let me write that down. It's Cr2 plus, and that is losing electrons to form Cr3 plus, and it has lost 1 electron. The E naught for that particular electrode is minus 0.41 volts. So this is the substance that is getting oxidized. And if you look at the other equation, then that's going in the forward direction. So I'm going to write it in exactly the same way in the forward direction. So it's Cr2O7 2 minus plus 14H plus 1 ions plus 6 electrons, and what is being produced is 2 Cr chromium 3 plus ions plus 7 H2O molecules, and the E naught for this reaction is 1.33 volts. So I've written down the two reactions, and if you look at the two reactions, you will notice that the first one, the oxidation part, Cr2 plus is just losing 1 electron, whereas the reduction part, dichromate 6 ions, are gaining 6 electrons. So 6 electrons are being gained, so 6 electrons should be lost as well. So I need to multiply the first equation by 6. If I multiply it by 6, then the number of electrons lost and the number of electrons gained become equal. Now the last step is I need to add the two equations up, the reactants and the products. If I do that, so it's 6 Cr2 plus ions plus dichromate 6 Cr2O7 2 minus ions plus 14H plus 1 ions plus 6 electrons. And in my products I have 6 Cr3 plus 2 Cr3 plus 2 Cr3 plus 7 H2O and plus 6 electrons. These electrons are going to get cancelled out, so let's remove those electrons. This would sum up to be equal to 8 Cr3 plus ions. So let's cut that out, add them together. So the overall equation is going to be 6 Cr2 plus ions reacting with dichromate 6 ions, acidified, producing 8 chromium 3 plus ions and 7 water molecules. So this is my overall reaction, overall redox reaction that I have predicted. In step 4, I'm going to find the E naught cell for this reaction. E naught cell can be calculated by subtracting the reduction potential minus the oxidation potential, or the higher potential minus the lower potential. The substance that was getting reduced, higher potential, is 1.33 volts. Substance getting oxidized is minus 0.41 volts. So I just need to calculate the difference. So it's going to be 1.33 minus 0.41 volts, and the answer that I get is coming out to be equal to 1.75 volts. Now remember, the greater the difference between the two potentials, the greater the difference, which is coming out to be 1.75 volts, the greater the difference, the more fast the reaction is going to be, it's going to be more feasible reaction. So 1.75 volts is a very large value, which means that this reaction would probably be very fast.